Hello, this is Pat Kelly. Okay, in this problem, they're asking us to find the general solution to this linear differential equation. These are pretty cool little guys because what they require of us is some old school algebra that hopefully you're still good at. So what you do for these linear differential equations is you take a look at what's given to you with the differentials, the y double prime and the y prime and even the y, and you come up with what's called your characteristic equation, which looks like a good old algebra 1, I guess, quadratic. You take this coefficient of 2 and you make that coefficient times m, whatever variable you want really, squared plus 3m minus 2 equals 0. So your characteristic equation looks just like this guy, but with m's instead of the y's and y primes and y double primes. And the algebra that I was talking about is you just go ahead and solve this quadratic. Factor it if it factors, use your quadratic formula, you do whatever it takes. I do think this one factors pretty nicely. If I do a 2m and an m, and I think I'm going to do a 2 and a 1, positive and negative. You can always FOIL the check, right? Looks good. And when you solve this quadratic equation, you get m equals 1/2 or m equals a minus 2. That's great. That's your algebra. And the way that ties into our differential equations then is that these two different values for m actually become coefficients to the exponents of an exponential expression. And that's a lot easier for me to write than actually say. So let's see this over here. I'm going to throw some subscripts right there and there just to line up to our answers over here for the differential equations. Y sub 1 I would get from my m sub 1. And what I was trying to say is that we have exponential expressions and the m becomes a coefficient up in the exponent of x. Okay, so that's where the 1/2 is going. And you also have a y sub 2 from your second value of m. And it's also going to be e raised to a power where that negative 2, in this case, becomes a coefficient of x. That looks great. And to finish, you just put it together with a single y. And I'm sure you learned a little bit about linearly independent functions. You combine a linear combination of these. And the way you do it is just throw an unknown constant in front of this guy, the first one, e raised to the 1/2 x, plus and a different unknown constant in front of this guy, e raised to the minus 2x. And as a whole, that's your final answer. Okay? Hope that helps, but of course you go practice some on your own.